Okay, good morning, everybody. So we talked about lambdas yesterday. So I wanted to, before we talk about API Gateway and how we can integrate lambdas with API Gateway, let me go ahead and create a couple of lambdas first thing in the morning, and then we'll test them. Okay, and then we'll kind of associate it. We ran into a couple of issues yesterday. Okay, and I'm going to explain why we ran into those issues. So I'll try my best to explain them here. Okay, let's go ahead and get started. Go to Lambda service here. So I have a couple of Lambdas, so I'll just go ahead and delete them. So first, let's start with the Node.js, simple Hello World app. So we can start from, you can say node 1. Okay, so I'm using Node.js here, and then actually I don't want to author from scratch. We can use the blueprint here, right? So search for hello, and then you have this hello world, and I want to use node. So let's call this as a node 1 function. Okay, create a new role with basic Lambda permissions. So take a look at this execution role here. Create a new role with basic Lambda permissions. So what it means is your Lambda, this particular load one Lambda function will assume what it does behind the scenes is that it will create a new role and then attach that new role to this node one Lambda function. And with the basic Lambda permissions, meaning what does basic Lambda permissions mean? Well, it needs to be able to create a log group and keep writing into CloudWatch. Essentially, that's all it is. So it needs to be able to do that. Only then, your Lambda will have access to the CloudWatch, and only then it will be able to write to the CloudWatch. Okay. Otherwise, you will not. Yeah, your Lambda will not be able to write to the CloudWatch. So you need, basic rule. I will show you. Just stay with me for a second here. Just observe that there is a new role that's getting created. But if you already have a role, you can associate that also. You can use an existing role. But let's go ahead and create it. And then this is how our Node.js code looks like. It's a very simple node. I'm not a node expert. I hardly wrote few lines of node code. So, but I'll show you how simple it is. Without needing any other external IDE, you can use AWS, inline editor itself for simple Lambda function here. We saw this yesterday. So, like in Eclipse, you have this Control D, right? Control D will delete the line. So I just felt it yesterday. So I used, out of habit, I pressed Control D and then it worked. So console.log, my first node function has been called. So this is your node function. This is an index.js. Index.handler is your method name. So, and that's it. Pretty much, everything else is basic. So just go ahead and save it. Okay, this is your a simple Lambda function written in Node, right? So we can unit test it. Oh, by the way, before we unit testing, this is your configuration piece. This is where you can add your trigger. And let's go to permissions here. In the permissions, this is the role that got created. Okay, let's go take a look at it. We can click on it and go to the, it opens up a tab. We can take a look at it there. Or here, by resource or by action, click on action. So this particular role has 3 policies attached to it: create log group, create log stream, and put log events. If you don't have them, then it will not have access to CloudWatch and it will not be able to write to the CloudWatch. This is one of the issues that we ran into yesterday. So, and another option is click on this role and you can do the same thing and see here permissions. So AWS Lambda basic execution role, take a look at it. So allow create log group, allow create log stream, okay, and then allow put log events. So we created this. Go to configuration. Okay, we created the simple Lambda. So go ahead and create configure test events, and a simple JSON. Okay, yeah. Let's say name. Okay, a simple JSON, hello world. We call it test1, and then go ahead and create it. So you created this test event. Go ahead and click on test, and then you tested it. You just so your return is now because you did not return anything from your function. Okay, take a look at this one. My first node function has been called. So that's the, see here, this is your console log has been printed. Since you did not return anything from this Lambda function, your return is now. Okay, and now what we'll do is let's go to our CloudWatch. CloudWatch, click on your log groups, and then this is your node one log group. Click here, and you will see that my first node function has been called. Okay, you can actually go delete all the log groups, even node one. Let's go ahead and delete the log group and test one more time and refresh the page. Refresh the page. Okay, so click on node one. So yeah, my first node function has been called, right? So what you can do now is, this is your console log. You can say return. My function is returning something. Return. I'm returning a simple text. And then go ahead and click on test. Now you will see the return. So this has been returned, and then go to log groups, and then you will see the second log event. So this one has been called. I know we didn't change anything there pretty much from the previous, because we didn't change the console log, right? If you want to, you can change it. So you got the point. There's nothing. So you'll see that, and you will see a third event there, and yep. So this is your third event. This is your log statement has been changed, right? So this is I wanted to show you a simple node function, and we did this yesterday, but we ran into issue with the CloudWatch. That's why I wanted to show you that that specific permission. This is one of them. So I got this simple node functions. Now what I wanted to do is I wanted to attach this one. I want this. I want to attach a triggering event. So I want my function to be invoked when I place a file in one of my S3 buckets. So click on add trigger, select your S3, and then S3 bucket. Next step, rather data setup. So when I select this one, and then for any put events, okay, I want this Lambda function to be called. Click on add. And this was the error we were getting yesterday, right? So we're struggling to find out why. So what I found out was, I'll show you on this particular S3 bucket, there is already an event exists. Okay, when you place a file, when you do a HTTP put in that S3 bucket, meaning when you create an object or when you update an object, okay, the event has to be raised. My Lambda function should be called is what we are trying to say. Correct? That's a triggering. But there is already an event and it can only raise one event. So that's what we failed to realize that yesterday. So let's go ahead and let me show you what's happening there. Click on S3, go to next step, weather data setup, go to properties, come down, events, receive notifications when specific events occur in your bucket. So there is already a Lambda function that was attached to this one. Okay, you cannot attach multiple. So if you need to, if you want multiple things to happen, what you need to do is, rather than calling the Lambda function on this S3 event directly, rather post a message to a simple topic. Okay, a simple SNS topic, and then have multiple subscribed to this. So multiple Lambda functions. So have that topic, push that message to multiple Lambdas. You can do that. So you have this publish subscribe model, right? So you'll have to use that one. So you cannot raise multiple events. So what I'll do is I'll select this event and click on delete, save. Now I don't have any events on this one. Come back and try to save it now. Click on add, it will work now. So that's what happened yesterday. So those are the two scenarios I wanted to show you.
Hey Venkat.
Yes.
This is Srinivas. So yesterday also I observed when I selected the existing one of my bucket, which was in different zone, then I got an error saying that they need to be in the same zone.
Right. Region, right?
The region, yeah.
Yep, exactly. Thank you, Srinivas. So that's about Lambdas and how you can attach the triggers, right? And we did, after that, subsequently we did, we placed a file in S3 that triggered Lambda, and that Lambda went to S3. We wrote a Java-based Lambda function that went to S3, got the file, parsed the file, stored the data into RDS. We did all of that beautifully. So now what we'll do is, let's talk about how can we attach this one to not an S3 event. How can a Lambda be used to process the HTTP requests? How can I use my Lambdas to process HTTP requests? So in this case, it's a S3, right? S3 is the triggering event, and you have SNS top, you have SNS, SQS, all of this, and you have your DynamoDB, the multiple triggering points. But how can I use my Lambda to respond to a HTTP request so that I can build serverless APIs or serverless websites? How can I do that? Let's say I'm an API author. Okay, I'm publishing APIs to I have this popular weather data that I want to publish them as APIs, so that all the phone apps like Android apps and iPhone apps can start using my APIs. You guys know that, right? I think iPhone weather app, they consume the APIs from Yahoo. At least that's what used to be. I'm not sure now. But so all Yahoo was doing was providing the APIs. Even if you remember, now Apple has its own Apple Maps, but it used to be, Google Maps used to be the default maps in the original iPhones and all, right? So even in that case, what Google provided was just the APIs. So they were API providers, and Apple was the consumer of those APIs, and it provided. Apple is good at putting things together, like in the UI area, UI UX area. But Google is good at providing the APIs. So that's how they did it. Okay, that was the collaboration between those two companies. Anyways, so the point here is that I wanted to provide APIs. And then one option here is that I can go ahead and provision EC2 instances. Within that, I can install Tomcat like app server, and then deploy my web apps, etc. But I don't want to pay for EC2, and I don't want to worry about the availability. I don't want to worry about the scalability, and I don't want to pay more than what I use it for, because I don't know my scale. Initially, maybe I get one API per day. I don't want to pay for this EC2 instance, but I could eventually get 10,000, but I don't know when. Maybe some days I'll get automatically. Yes, I can use auto scaling group and all, but it's still, I don't need to worry about the servers. So how can I create this serverless API experience? That is where AWS has an answer for this one in the form of a concept called API Gateway. So API Gateway is not a new concept that's that started by AWS. Okay, it's been out there. So there are multiple API Gateway vendors. Like one of the most popular one is Apigee. So Apigee was bought by Google, a company called Apigee. So Apigee was bought by Google a couple of years back, and there are more API API gateway vendors like Layer 7, Apigee. I think IBM has what's that called? Data Power. So it pretty much, what the concept of API gateway is that, let's talk about it. What it is fully managed service that enables developers to create, publish, maintain, monitor, and secure APIs at any scale. Let's talk about it. So let's say you're building microservices. So you have one microservice for person API, and you have another microservice for your whole organization API. And if you have another service for order API, so where you can, customers can come and place the orders. And you have another microservice for admins. Let's say, you're working for Amazon. So there will be an API for products. There will be a separate microservice that's for products. So administrator will add new products so that Amazon can start selling it. So there will be several microservices. So all these microservices, there could be hundreds of microservices, but all these microservices, they have certain things in common. They call it cross-cutting concerns. So everybody, you have to provide a seamless API. You don't want your consumers know that there are 100 microservices. Everyone goes through a different API. No, you want to provide a one seamless experience to all of them. So what you will do is you will provide a front gate to all those microservices in the form of a concept called API Gateway. So API Gateway will act as a proxy for all of your incoming traffic, and then you can provide the rules there. So this request, if somebody comes with slash products, send this to product microservice. If somebody comes with slash orders, then send it to your orders microservice. If somebody comes with slash auth, send it to authentication microservice. If somebody comes with slash token, then send it to token service. So you can have several microservices, but you can provide a one seamless API experience. And number two, you can maintain authentication at a single place. So all these microservices don't have to worry about authentication. All these microservices don't have to worry about authorization. Both authentication and authorization can be pushed up the chain, and then they'll be taken care at the front gate itself in the form of API gateway. And in addition to that, you will get metrics. So how many times it's been called, and what's the data look like on a typical day? What's your trend look like? API trend look like? Well, morning time, like a drive time. Let's say you are building some APIs for these car companies. Okay, so during the drive time, your API consumption will go up, and throughout the day it will be kind of stable. But again, drive back time, about 5 o'clock or something, your API will spike. So you'll be able to monitor it. You'll get the metrics, and you can secure all of them. And another benefits of API Gateway is versioning. You can maintain multiple versions of API. Let's say you have your products API. Products V1 will work in one way, products V2. You'll be able to support both of them because you have two different microservices there. And your API gateway with a simple /V1 will send it to old microservice, and /V2 will send it to the new microservice. And then you can do a market research and to see how many people are really interested in this new version, and and you can adjust your new version. If people are really using it like how you thought, then you can, at some point, you can deprecate your version 1 and bring all of your clients to version 2. And there's a concept called canary deployments. It's a feature by feature deployments. Okay, you can do that. And there is a concept called blue-green deployment. So API Gateway will make it much simpler even to do the blue-green deployment, because everything is nobody goes through this. Nobody goes to these microservices directly. You have the front gate there. Okay, so this API Gateway will act as a proxy pretty much. And once you get the request, API Gateway can transform the request and then send it to the backend microservice. Once microservice returns the response back, you can transform that response and then send it to send to the client. So you can do that, pre-processing and post-processing also. So a lot of advantages. And also the another beauty is that, I have benefits here. So you have your traffic management, authorization and access control, monitoring, API version management, throttling requests to prevent attacks. Okay, you can say that this API can only be called maximum of these many requests per second. So you're throttling it so that you are saving your backend resources by throttling it. So you are not letting some attacker to bring down your microservices because you're putting your throttling. Or even because of some issue on the client side, if client bombards your APIs with so much load, then you could potentially bring down your backend microservices. So you're throttling in API Gateway. So you can do that. And also client-specific authentication and authorization. Let's say you have, your APIs have, my weather API became so popular and I have two clients at this point. One is Apple, the other one is, let's say, Microsoft. Both of them are using it in their apps. Okay, so I can provide, one client ID secret to Apple, one client ID secret to, Microsoft, and I can use WAUth for, WAUth 2 standards for both of them. And then I'll be able to throttle it per client. I'll be able to throttle across the API, and I will know, how many, what's the traffic looks like for Apple, what's the traffic looks like for the other client, Microsoft. So you'll be able to do all of this with API Gateway. It's a very powerful concept. In fact, AWS has very how do I say, it's a very simpler approach to this. They are not, that's not their bread and butter. Okay. So there are powerful API gateways out there. You know, look at Apigee console and look at Apigee metrics. You'll understand it's really powerful. Okay. So Amazon's, it's very rudimentary. It's basic stuff, in all fairness. Okay. Before we,
Hey, Venkat.
yes.
So, I mean, does Amazon allow outside API gateways to be used or no?
Can you repeat that?
Does Amazon allow other API services to be used?
Absolutely. So let's say you have your microservice deployed somewhere else. If you want to, let me see if so if you want to use Amazon API Gateway, but your microservices are already built somewhere else or at your own place, like, okay, you expose them and Amazon API Gateway, you can gladly use it. Or you can use Amazon's, microservice architecture. You can use your EC2 instances, or you can use your not Lambda so much, but you can use your EC2s, and you can deploy them as APIs, and you can use some other API gateway. So it's a decoupling. So you don't have to use both Amazon services. You can mix and match is my point. Did I answer your question? So you
Yes.
can use both sides. You can use API gateway and your backend service can be different, or your backend service can be deployed in Amazon and you can use API gateway, some other API gateway. So you can do both ways. So before I show you how we can do this API gateway, and why is it important in this particular context is, API gateway, especially this AWS API Gateway, makes it possible to call these lambdas. So when I make a HTTP GET call to an API, that can call, or that can trigger a lambda function. That's the beauty. So I'm building a serverless API here. I don't need an EC2 instance there. When I make a HTTP call, it goes to API Gateway, and API Gateway, you can write pre-processing if needed. Otherwise, you just act as a proxy. You just pass it on, just pass through. You pass that request coming from the browser to as is to the backend. Okay, in some jargon says, API proxy, or API gateway is called proxy, and your backend service is called target service. Or in this case, backend service. You can call target, backend, whatever it is. So anyways, the point here is that API gateway is acting as a front gate. It takes the request coming from the browser. It will act as a proxy and pass on your request to the backend service, and that backend service can be Lambda. It doesn't have to be Lambda. It can be, several other AWS services like EC2, definitely. But the beauty is Lambda. It can trigger the Lambda so that you don't have to manage the server. So what we'll do is we'll create a Lambda function that takes a HTTP request, and it gives some sample HTTP response back, and put a simple API gateway in between. And then you make a HTTP call and your Lambda gets triggered. That's the beauty, without having a server. You see how things are getting connected? So I'll show you an example what I'm talking here. But before that, let's talk about some jargon. In the case of AWS, Amazon, AWS API Gateway, you have this concept of API. So you'll create, that's the first thing you do. You'll create an API. API is nothing but a collection of resources and methods. Well, what is a resource? What is a method? How many of you know what's a resource-oriented architecture is? In the resource-oriented architecture, or ROA, everything is a resource. Pretty much, this is your object-oriented object-oriented programming model, everything is an object, right? You have your person object and you have your order object, account object in this particular case, right? Similarly, in the resource-oriented architecture case, you have everything centers around the resource. You have this concept of resource that must be a noun, not a verb. So you have your person. So it's a person service, your order service, account service. So all of them together, you can combine them and create one single API. So one single front gate. So slash v1, and then you can call your person, order, account, etc. So within each resource, you have a multiple HTTP methods. The beauty of the resource-oriented architecture is that, so if I make a same /person call, /person, and if I make a HTTP get on it, it will give me, actually /persons is, yeah, persons. In a REST taxonomy, right? /persons will give me get all persons. If I want a specific person, then I'll use person/ID. Let's say 123. Then if I call HTTP get method, HTTP get on this particular URI, it will give me get person with ID 123. But if I make a same call with the person/123, if I do a HTTP post, then what I'm doing is create a person with ID 123. If I do a /persons/123, same URI, but if I call HTTP delete on it, then delete a person with ID 123. If I call same /person/123, if I do a HTTP put on it, then I'm updating the person. Update a person with ID 123. Does it make sense? This is a perfect resource-oriented architecture. So what's a resource here? Persons is a resource. And these are called path variable or path parameters. So these are called path parameters. You can have, and there is that whole REST taxonomy is there. If I want to do, let's say, if I want to get one person addresses, right? Or if I want to get persons accounts, let's say persons/123/accounts. And if I do a HTTP get on it, you know what it does? It will get all the accounts of a person with ID 123. So there is a person with the ID 123. That person's all accounts, give me all the accounts associated of a person with the ID 123 is what we're saying. If I call the same thing /person/123/accounts with a HTTP delete, then I'm saying delete all the accounts for this particular person. So it's, you got that REST endpoints, REST taxonomy, etc. Okay, that's about the resource, and method is nothing but HTTP methods. You got this, this also. And there is another concept called stage. So once you create the API, then you want to deploy that API. Every time you deploy an API within Amazon's context, you will deploy to some stage. You know, things like stages like dev, QA stage. Every single time you deploy your API to a stage, either you are updating an existing version or you can create a new version. Okay, it's a snapshot of that API at that point in time, whatever the changes at that time. So that's about it. Let's take a look at a simple demo. So in this demo, what I wanted to show you is a simple Node.js Lambda. Let's create a simple Lambda, Node.js Lambda. So we just wrote hello world Lambda function with Node.js, right? What we'll do is this will take a HTTP request. Essentially, it's a same event, same context and everything, but you will return a hard-coded weather data. So you will not be talking to any RDS or any other database, no runtime. It's you just hard code it and send it back. How do you do that? I'm going to show you that. And then we will do another demo, Java code. That's where we'll expose our weather API. Any questions at this point before I jump into it? So let's go ahead and create a function. And I can use a blueprint here also and search for HTTP. You will find a microservice HTTP endpoint. This is written in Node.js. It's mainly for API Gateway. Okay. Configure it. And I'll call it Node for API Gateway. Okay. So here it's creating a new role from AWS policy templates. So it looks like this particular blueprint that I have taken it. It's talking to DynamoDB also. Okay, no problem, but we will change it anyway because we wanted it to be as simple as possible. So I can create, so I don't need Lambda. I'm not going to worry about DynamoDB or anything. So what I'll do is create a new role with basic Lambda permissions. In fact, I can reuse the one we just created. Now, here you can attach API Gateway trigger directly, but I'm not going to do that now because we want to do it in a little differently. First, I'm creating a simple Lambda function. Okay. And this is the Lambda function code. I'm going to delete everything and keep it simple. Create function. This is the code that template gave me, but I'm not going to do that. So how does our code look like? Our code looks like this, guys. Look at it. So you have your handler method and you have your event and context. So what I'm doing is I'm declaring a headers constant. So content type is application/JSON. This is the default content type also. Okay. But if you want to associate a Lambda function to your API gateways, the content type, one way or the other, the content type must be application/JSON, meaning you have to return the JSON. And then I return this body, constant body equal to zip code is 48083, temperature is 72F. So this is my simple JavaScript JSON object. And then I'm returning another JSON object. I'm here saying that status code is 200. So HTTP status code 200 I'm returning. And then I'm returning body, and I have this body JSON object. You must return this. You can't return this as is. It must be in a string format. So you do a JSON.stringify and then your headers. So you have to return a JSON object with 3 attributes in it: HTTP status code, headers, and body. And in your headers, you have to have the content type as application/JSON. Does that make sense? It is that simple. I'm just hard coding body. If somebody calls this function, this is what I will return. I will return all of this: HTTP status code as 200, body as this one, and headers as that. And then we will attach API Gateway as a trigger. So let's go there and click on this function. This is the function code that he wrote. He was doing a lot more. So he's connecting to the DynamoDB and all. I'm not doing any of that. So delete it. I'll copy this simple code here. a simple Lambda function that returns hard-coded weather data. So when somebody calls this guy, I'm giving this hard-coded weather data. Any questions there? I'll go ahead and save it. So very, very, very simple Lambda function, right? Everything you can leave it as is. You can leave everything default. Let's go to permissions and take a look at it. This is the role name. Okay, let's go by action. Well, you can create a log group, create a log stream, put log events. Well, okay. So you have access to write into CloudWatch. So that's good. That's good. Now what we will do is let's unit test this guy. So configure test events, and I will call this as Amazon API Gateway. Sure. So this JSON will be dumped to this. This JSON will be sent. This JSON will be sent to our Lambda function. I'll call this as a test one. Yeah, I don't need to make any changes because I'm not inspecting any of these requests anyway. I'm not looking at the headers. I'm not looking at any of these path parameters, stage variables. I'm not doing anything. I'm just returning. It doesn't matter what the request is. I'm returning a hard-coded data. So go ahead and create it and then go ahead and test it. Well, it's successful. Let's take a look at the details. This is my response, guys. Response is status code 200, body, it's a JSON, the string format, headers, sure, looks good. And I can put some console logs here. I can actually do this one, or I can, my node function has been called. So your Lambda itself doesn't know that whether it's API Gateway triggered it or your S3 triggered it, no idea. So yep, my node function has been called. And if you look at your CloudWatch, you would have seen, you'll see that. There you go, node for API Gateway, and you have 2 triggers there. See that? My node function has been called. Well, okay. I mean, we got this. We did this this morning also. So I have this function. Now I don't have a triggers, right? So I can attach triggers in 2 different ways. I can go here and add a trigger and select my API Gateway, and I can start creating. Here. You can definitely do that. Looks like I have 2 APIs there. I'll go ahead and delete them. But you can definitely create an API and attach to your Lambda, or you can go to API Gateway here. Go to API Gateway services, and then I have two APIs. Let me delete both of them. I was playing with it, too many requests. So oops, let me go ahead and delete this guy. Number of APIs you can delete per minute. Okay, so we'll wait. Let's go ahead and create a new API. We'll come back and delete it after 1 minute. So this is how it looks. When you go to API Gateway, so this is how it looks. It will show you all the APIs. Okay, and then you can click on Create API, and then you have a couple of different types of APIs you can create. You can create a simple HTTP API, or you can create a WebSocket API, or you can create a full-blown REST API. Well, full-blown REST API is where you will have this concept of resource, methods, it's a full RESTful endpoints, the complete API set, with all the methods, okay? And the WebSocket API is used for your stateful applications, like your chat application, for example. Okay, you can create a WebSocket API. So there is a connection open from backend to the front end to the browser, and then browser backend can keep sending the data to the browser. So WebSockets is, let's say you are, if you look at this ESPN, when there is a game, football game going on, how you get without you having to refresh the page, or without making this Ajax poll, you can do a push notification from server to the browser. So you can use WebSocket API, or you can use for your gaming. So you can use your web gamings and all. So you will have the TCP connection open, completely with the WebSocket API. But REST API is what we wanted to do it. One is a public REST API. The other one is private REST API. This is open only within your VPC. So let's go ahead and create the public REST API. Click on build. And now select whether you would like to create a REST API or WebSocket API. Well, I want to do a REST API, and it's a new API. And my API name is my simple node API. Okay, have the same description. Endpoint type. Do you want your endpoint to be regional? It's applicable within the region that you are in, or you can do an edge optimized where it will use your edge locations. But I'll go with the regional, or you can have your private. I want to go with the regional. I don't need edge optimized for this purpose. So click on create API. Well, my first API, my simple node API got created. So the slash is at the root level, right? So within this, now you have this concept of stages, authorizers, gateway responses, all of this. But let's worry about one at a time. Click on actions, and then let's go ahead and create a resource here. So within this API, let's go ahead and create a resource. So let's say person is my resource. Okay. So if somebody goes to my simple node API and then do a resource path is my URI /person, when they call /person, then what should happen? Okay. So /person is my resource. And within /person, you can have a HTTP get, you can have a HTTP put, options, delete, all of that, post, right? So within person, I'll say create a method. So I created a resource here, and I can create one more resource though. Within the same API, I can create now /order /person /items /products /auth, everything. So they all come under one API. You're grouping them, your resources. So within resources again, within resource again, you have your method. So I'll do a HTTP get call. So when somebody makes a HTTP get, meaning /person HTTP get, what should happen is what we are doing now. So when somebody goes to your API, your my simple node API, which is / and then make a call /person and do a HTTP get on it, what do you want this API gateway to do? Well, I want my API gateway to pass on that request to Lambda function as a simple proxy, meaning just pass your HTTP request as is to the Lambda function, and then once Lambda gives the response, pass it back to the browser as is without doing anything. Simple proxy, act as a simple proxy. Where do you want to do that? Lambda region is in the same region, and Lambda function. Well, your API gateway, when somebody calls /person, I want my node to be called, right? So where am I? Go to Lambda, and my node for API gateway is this is my function name, Lambda function name. I can give Lambda function name, it will automatically fetch the Amazon resource name. Click on save. You're about to give API Gateway permission to invoke your Lambda function. This is your ARN of your Lambda. Okay, sure. Go ahead and give it. So the way we configured is that if somebody makes a HTTP GET on this /person URI, then I want my Lambda to be called. Take a look at it. This is the beauty. When a client, your browser makes a call, okay, your method request. So this is what gets called. So if somebody calls /get, /person, essentially. So if you do a HTTP GET on this /person, okay. So your proxy will take it and then pass on to your Lambda, and your Lambda will return it. Integration response, you're not doing anything. Proxy integrations cannot be configured to transform because we defined this as a proxy, meaning there is no transformation required here. Just pass it on as is to the client is what we are saying. So see here, there is a button called test. Click on test, and then you can test it. So we did not deploy this API yet. We did not deploy it. So we are just unit testing it to see how it works. You can pass any query string parameters, and you can pass your headers. Nothing. I don't need to pass anything. I'm passing /person HTTP GET call. I'm doing it. Let's go ahead and test it. I got HTTP status code 200, latency 27 milliseconds. My response body is hard-coded zip code 48083 temp 72F. That's exactly what we put it in this Lambda function, right? If I change my Lambda to 172 and then 48085, hard-coded. Now test it again. Your response will change now, 172F. So when I made this HTTP GET call on /person, it invoked Lambda. Earlier, yesterday we have seen the Lambda to be invoked based on S3 events. Now Lambda is invoked based on HTTP events. That's where your serverless APIs, that's how your serverless APIs are made possible through the use of Lambdas with the power of API Gateway. Okay, this is just testing. Now we just unit tested it. You can take a look at all the logs, what exactly getting passed to your Lambda, all the headers that's getting passed. You can take a look at it, and endpoint response body, endpoint response headers, endpoint response body before transformation, method response body after transformations. So you can look at all these logs, okay? And you can look at your CloudWatch. Your CloudWatch will give you the Lambda logs also. So we unit tested it. We are happy with it. Yep, it's working like it should. Now go to actions and let's go ahead and deploy this API. So where do you want to deploy this? Well, I'm creating a new stage. Let me deploy this in my QA environment to start with and deploy it. So at this point, whatever the settings my API Gateway has been deployed to QA, and it will give me a URL here. So click on this URL. This is your API URL. So you are trying to call the API URL directly. This is your stage, right? But this is your /, right? So, but what we configured is /person. So you have your /person HTTP GET. This is what we need to do. And now when you call it, your zip code 48085 temp. So, and I exposed it, and I don't have any authentication or any of that. It's a public API. So you all can try, and I can take a look at my Lambda getting called.
Venkat?
Yes.
In real application, in real production application, you won't configure these manually, right?
You won't?
Meaning, will you? I mean, there could be like hundreds of endpoints.
Right.
So in that case, would you write a script that would kind of grab your endpoints and then configure them here, or?
You can do that, but actually, I'll tell you my own experience. Okay.
Okay.
I've not used Amazon API Gateway in a full length. I've used Apigee quite a bit. In Apigee, we did everything. So we configured all those APIs. In fact, ours was API company back then. Okay. So we were providing APIs to all the automotive companies. Okay. So we had a ton of microservices, and we configured Apigee. They call it proxy also. Yeah, they call it proxy. So proxy, and you deploy them with every single time you deploy, you'll get a brand new version number. So once you configure all of that, what you can do is you can download the entire proxy, and then you will have the code in the form of XML. That's how Apigee works. Okay, everything is configured in XML, and then you can put it now, you can move it across different stages, or they call it environments, different environments. You have your dev QA stage, but it's very likely that you will do it. Yeah, I mean, you can script it. That depends on your API gateway.
And that means through AWS, I have CLI commands to do these.
Oh, yeah. If your question is specifically about AWS API Gateway, you have CLI, you have SDK, you can definitely script it.
Because these need to go through version control too, right?
Yes, absolutely.
Okay.
All the API gateways are typically all of your SDK or your CLI. You'll put them in your bit bucket, and yes, they have to be version control.
Okay. And could it be like, is there a possibility to automate, like say you have a Spring Boot with a Swagger turned on and you have all your endpoints exposed, and you can automatically?
Absolutely. I thought, I'm glad you mentioned. So create import, if I'm not wrong, you can import your Swagger API.
Perfect. Okay, perfect. Yeah, this is realistic. Okay.
Yeah. Oh, it's not hello world by any means.
Okay.
It's a real. Actually, you can upload your the API, whatever the API gateway that we created, right? You can upload it as a Swagger API. You can put the additional documentation features, and you can upload it. Okay. Sorry, you can. Did I want to say upload? Or you can transform them as a Swagger API. That's what I mean. Or if you have a Swagger API already, copy paste here, and it will automatically be imported. So absolutely. So that's about a simple API. Okay.
Venkat.
Yes.
So the endpoint what we received from Lambda function, right? When we create API, I mean, we can definitely redirect to the native endpoints, right? What we have. Custom URL, I mean.
Sorry.
Okay.
What's the question?
No, that's okay. So let's see the endpoint what we received here, right? With QA. Yeah, we can always able to transfer that to our custom URL, right?
Absolutely. How do you do that, by the way? So what Ketan's question is, I have this URL that's created by Amazon. So how do I make it a custom URL, like a vanity URL, right? That's what they call it. So how do you get it? How do you get it?
Route 53.
Route 53.
Precisely. Yes. So your Route 53, you say alias equal to yes, and then you have to choose your you have your API gateway endpoint there. Make sense, Ketan?
Yes.
And everyone.
Yep. So Route 53 would have this alias available there. Okay.
Yes. So that's about a simple API gateway, a simple API, and how a simple API can call Lambda. So the beauty, we are combining the powers here. We have the power of API gateway, and we have the power of Lambdas. And now Now, all of you, please, if you have some nifty code, either Node.js code or Java code, it doesn't have to be nifty. I mean, you know, if you have some code, deploy it out there, keep it in Lambda. Amazon doesn't charge you for your code until it gets executed. So Amazon only charges for your compute cycles, okay? And then put an API gateway and put it out there. You know, you create your simple Angular-based application or a simple HTML page, and then you put your links there, okay? Let's say you enter a simple text box, enter your zip code, and then submit it, and you call that API, and that API is calling Lambda, and Lambda is returning back to the API gateway, and API gateway is acting as a proxy and giving it back to your browser. Make sense? So with that, you are not paying for your EC2 instance 24/7. You have your code deployed out there. If somebody calls, you will get charged. And in fact, I believe it's how many Lambda calls are free? I thought it's 1 million. AWS Lambda calls pricing. I think it's a per million. Yeah, 20 cents per 1 million requests. And the free tier provides 1 million requests. So the monthly compute price is this one per gigabyte. Yeah, see this one? So it's crazy cheap. Lambdas are crazy cheap. A lot of people are going with this approach, you know, serverless, where their bill should have been like a $10,000 or $50,000. In fact, they are paying in hundreds. Big you know, companies also. Just wanted to, you know, throw it out there. Okay, guys. This is about a simple Node.js based Lambda. We invoked it, and then through API Gateway. Beautiful. This is good. Now let me see if I can I can deploy this guy, because it's been more than a minute. Yep. Okay. Now what we will do is we don't want simple. We don't want hard-coded stuff. We want dynamic stuff. You know, yesterday we created a Lambda function that gets invoked when I upload a file to S3 bucket specifically, that and then our Lambda code will get the object from S3, parses it, and puts the weather data into database table in our RDS. This is our RDS. Something wrong? Let's go take a look at it. Let's test it. Okay, success connect, and okay, let's go check. Okay, this is how the data got loaded. Now what we will do is, let's expose a REST endpoint. What that guy does is, you pass your zip code as a path variable. You pass your zip code as a path variable, and it takes your zip code and do a lookup by making a database call to your RDS and gets the temperature, and it will return it. So your Lambda will return it to API Gateway, and your API Gateway will act as a proxy and return it to the browser. Shall we do that? So I did that. I will show you. I'll put this in GitHub, but I'll explain it. So let me close all the other stuff. So let me close these guys also. Okay. So I created this project called API Gateway Event Handler 1. In this, I have an event handler, API Gateway Event Handler. So API Gateway Event Handler, essentially, your class must implement your request handler. You guys know that. That is what is a Lambda. Every Lambda must implement this interface called request handler, and it can take any input and any output. But in this case, the input is API Gateway Proxy Request Event. This is in AWS Lambda events. If you look at your POM XML, you will know that you need this AWS Lambda Java core, and you need AWS Lambda Java events. You need both of them. So this is your complete request payload when API Gateway invokes your Lambda whatever browser sends it. Let's say if you're making a HTTP put call, and if you send this big payload, the entire payload along with headers, everything will be put into this object, API Gateway proxy request event. Okay. And what you need to give back if you want to send something back to API Gateway is you need to give back this object, API Gateway proxy response event. This is for a proxied response. Ours is a proxied response. So essentially, this response has 3 sections to it. One is body, the other one is headers, the other one is status code, as a simple Node.js did it. So, and in the request here, okay, you can get the path parameters. You know what path parameter is. When I call, let's say /weather, let's say this is my resource here, okay? This is my resource and I'm making a HTTP GET call on that /weather. So it gives me, let's say /weather gives for all the zip codes, weather for all the zip codes. One second, guys. I'll mute everybody. Okay. So /weather, let's say it gives weather for all the zip codes, but I want a specific zip code. Then I'll call /weather /path variable. So my path variable is, let's say, 48083, and I'm making a HTTP GET call. Give me the weather details for this guy, is what we are saying. So this one is called path variable. This is not a request parameter. Request parameters, as you guys know, question mark, size equal to 10, something like that. This is your request parameter. But the /48083, this is a path parameter. So I want to use this API as a path parameter. So how do I get my path parameters? Well, your request object dot get path parameters dot get. So inside that, I'm expecting a path parameter called zip code. Does it make sense, guys? So I'm getting the zip code now. I'm logging it. And now I create a simple repository class. And repository, I'm passing the zip code and then say, give me the temperature. Give me the weather for the zip code. I wrote a simple method, and this simple method goes to MySQL RDS and select star from weather.temp lookup. It gets the temperature and creates a weather object, and it gave me the weather object. So once I get the weather object, I'm taking the temperature. So now I'm creating, oops, in fact, why am I doing this again? This is funny. So repo.get weather itself can, I'm getting a weather, right? So I can safely, I'm not sure what mode I was in, but you got your weather object there. Okay. Now, once I get the weather object, now I'm converting that into JSON. Okay. I'm converting that into JSON format, and it will give me JSON in the string. Okay. Because I need to pass as a string back to my, from my Lambda, right? I got the response body. I'm just logging my response body. And now I created a map called headers. And here I put it content type is equal to application /JSON. And I added, there's my response object here, right? API Gateway proxy response. This response has 3 sections. Body, I gave the response body. I gave the headers. I gave the status code 200. And I put a simple log there. It's that simple. Is there any complication in that?
Venkat, say your service is down.
Mm-hmm.
What do you do then?
What service is down?
Say the weather service is down.
Okay, let's be specific. So we have API Gateway, and the API Gateway is acting as a proxy, and your Lambda is acting as a microservice, as your as your backend. So you're saying your Lambda is, Lambda
No, not Lambda.
Okay.
You know, we have this concept of circuit breaker, right?
Uh-huh. Uh-huh.
So does that come into play here? How do you implement that here?
Well, that's little
Okay.
advanced.
That's
So
fine.
we
Okay.
have
Sorry
to
about that.
we can throw circuit breaker also in API gateway.
In
Actually,
API Gateway.
yeah,
Okay.
yeah.
Okay. Okay.
So, but that's little advanced. So let me not go there. Okay.
Okay. Thank you.
So.
That we
Mhm.
need to follow this body, header, and status. This is the syntax.
That's correct. That's correct. That's correct. You have to see here in the response, right? This object itself has that response dot set body. Yes, you are expected to follow this one.
Okay.
You have to return a JSON object. Within that JSON object, you have to have three attributes: body, headers, and your status code. And that's how it should be. Of course, your Java is helping you with your type safety, but in your Node.js you could go wrong. So what happens is in your here, if I say bodies instead of body or body slash body 2 or something like that, if I have a typo here, right? Then what happens is your Lambda is fine. Your Lambda is returning it, but API Gateway will not be able to parse that. And API Gateway will throw a specific error code called 502. Okay, it says that I'm sorry, this threw me a junk that I can't pass it back. I can't. I'm acting as a proxy here. I need to be able to, there's some contract between API Gateway and the backend. Okay, you have to follow that.
So we have to follow only JSON type response body.
Yes, yes.
Okay. What if we, any SOAP services do you want to expose as API gateway? Is it doesn't allow it?
Well, you have to go with your HTTP API, not REST API.
Okay.
Right, because we chose REST API,
Got it. Yeah.
we are restricted like this. Right, in your generic HTTP API, you can do pretty much anything.
For the SOAP, okay.
Mm-hmm. But you don't want to do for any practical purposes in 2020.
Yeah.
Okay, you have your body, header, status code. All of this is good, right? Any questions here?
Venkat, I have a question here. So actually what we are doing here is we just put this jar into the Lambda, right? I mean, we build a jar and put it into the Lambda.
That's right.
And then we will call that zip code, right? With the zip code. And then how does, what happens at the back end, and how do they know, the Lambda knows, right? So what is the data available in the backend database and also?
It doesn't. See, API Gateway, browser made a call /12345, right?
Yes.
So API Gateway is acting as a proxy. It is forwarding that request as is to your Lambda. So you got your request.get path parameters.get of zip code. You will get your 12345 here. So now you made a call to database and your database returned no response. You don't have data for zip code for 12345. What do you want to do that? Is totally up to you. Do you want to throw back another, or do you want to throw some generic, you want to give some dummy response? It's all up to your business, right?
But actually we are not running anything on our end, right? We just build it as a jar and then we just put it into the Lambda. So the API gateway will just forward the request to the Lambda, and then how does where it is deployed, and then back and there should be a server, right? Where
Right.
this code should be executed, and then it should as per this code, we expect something in some database, right? And then we are getting that data from the database and we are returning it back.
Hmm.
But we are not doing all that backend thing.
Exactly. You're not doing any of that. So you write your code, you deploy it, and you don't care how. You don't care how, or you don't care where it gets deployed. But what happens behind the scenes is that since it's a Java runtime, it will build a small container. So if the container is not readily available upon receiving the request from API Gateway, what your Lambda does is, AWS Lambda does is, it will check, do I have a container readily available in warm state? No. Then if it's not there, then it will create a container, deploy your code and initialize it and pass your request as is to your Lambda and synchronously waiting for the response back from the Lambda.
Okay.
Okay. So there is no concept of server here. That's the beauty. There is no server concept. There is, of course, without the concept of server, your code doesn't get executed. There is, but you don't know any of that. You don't know where it is deployed. Internally, it uses a simple, lightweight containers. So, and then it deploys your jar file into that container. Based on the parameters that you specified that you need 512 meg of memory. Go ahead.
Okay, so here in this particular example, we are passing one zip code and expecting some temperature, right? So the weather actually. So, but here we are not actually adding any SQL scripts or anything, right? Like how does the Lambda, like behind the scene, how does Amazon knows like, okay, I mean, they know like from the POM and all, okay, this dependency is there and all, but how do they like put the data into it and then retrieve it or something?
No,
Venkat,
Amazon doesn't know anything. Oh, 1 second, if you don't mind.
Yeah.
So see here, pretty much you wrote it. You wrote a piece of code. So I just explained about the Lambda, right? There is no concept of server there, but behind the scene, meaning for us, there is no concept of server, but it actually creates a new container and deploys your code, right?
Mm-hmm.
Now, this piece of code, you have your database out there readily available for anyone to pick up. This is a simple Java code that you wrote to go get it here. See here?
Okay.
So I have a database, I have a RDS. There is a prerequisite that I mentioned yesterday, right? The prerequisite is you have to have your relation for this application to work, for this example to work. You have to have an RDS, MySQL RDS, and you have to have a weather database. All of this exists in my account.
Oh, okay.
So I think we missed that, huh?
No, maybe it's my mistake.
No
Actually.
worries, no worries. See here. So that's a prerequisite. I'm glad you asked because other people may have the same concern. See here. So this was the prerequisite here. Before we start any of this one, I didn't go through this one again today because I thought we went through this yesterday. So the prerequisite is you have an RDS instance. I have a database called WeatherDB. And here, there's no magic here, Uma.
Okay. No, I got it. So
you have a database here, and you have your, this is your endpoint, your public endpoint, your 3306 port, and see here, I'm connecting here. See here?
Okay. Yes,
I'm connecting it.
So the database is also in the AWS, not, I mean, it's in your local machine. So
no, it's also in AWS, but it doesn't have to be in AWS. It can be anywhere, right?
Yeah.
This database can be in Google, and all I have to do is I'm giving my JDBC URL. See here, my JDBC URL.
Yep.
This JDBC URL, this host name can be anywhere in the world. This port number can be anything. This is my schema. This is my MySQL driver. This is my MySQL username and password. These are all the same username and password that I'm using for Oracle SQL developer to connect to it. There's no magic in any of that. A Lambda is not in the picture. It's simple Java code. Java code, you write your local code. This one, you run it. Forget about Lambda. Forget about Lambda. See here, I write a simple main class here. Okay. So hold your thought. Someone was trying to speak. Okay, so write new weather repository. Forget about Lambda, all of this one here. If I want to locally do it, let's say 55108, 55108, and I'll do a weather dot get temp. I'm getting a temperature here. Okay. So this line of code will work anywhere in the world. It doesn't, there's no Lambda is not magic, any of that. It's a simple Java code. I can run this guy. 16 degrees F. See here, it connected to this database. Somewhere I have in the world, I know this happens to be in Amazon. This happens to be RDS, but it doesn't have to be. I think you get the point, right? 80013, change it. What is that? 80013. So a simple line of code. 51 degrees. Yep. Makes sense? So it's so someone was speaking and I asked, is that Ketan?
Hey Venkat, this is Karuna. It was me.
Right.
All I was trying to say is the confusion is Uma is, looking at the use case as a whole, and what you were saying is, how we access the service. You answered the question. I meant to say, yes, there is a service behind that, whether it was hosted on AWS or somewhere else, doesn't matter. I mean, what you were explaining is, you don't care about, the service or the deployment of the service or the development of the code. And she was seeing as a whole, how to develop the service and all. I think that's where the whole confusion started.
Gotcha.
Yeah, thank you.
Anything that I can add or any other confusion or anything?
It's clear.
Okay. So I have this simple Lambda here. I'll go ahead and run as build. I'll call clean package and skip test. But I'm glad you asked, Uma. Let's okay. So it's my jar file is here, guys. So what I will do is, first step, let's go and create a new Lambda. This is a simple node 1, node for API Gateway. I'll call this as, now I'll do it author from scratch. I'll call this guy as weather No, I don't want to do get, okay, weather, Java weather, right? And my runtime is Java 8. Permissions. Permissions, create a role with basic Lambda permissions. Yeah, this is enough because I'm not making any S3 calls or anything. I'm making a simple, RDS call. And then in this case, 3306 is wide open. So I'm fine here. Create a function. And then let's upload this big jar file. Okay. So upload your jar file, go to target, and it's a 19 meg jar file. Okay. Java 8. And what's your handler class and method name? Well, your handler class and method name is your fully qualified handler class, including with your package. That's what I mean by fully qualified class name, colon, method name, whatever the method name is. In this case, it happens to be handle request, and go ahead and save it. I don't need any environment variables, but I told you guys the best practice is that these 4 should have been environment variables. You guys do that? and pretty much everything else is same. Let's go ahead and save it, and let's unit test it, and then let's add API Gateway to this one, and then we'll expose it as an API, and all of you can call it with the different zip codes and see how you can get different response. So while this is getting saved, your function getting saved, okay, it's saved already. And I can do configure test events. And what do I want to do? This is API Gateway, right? No, Amazon API Gateway, AWS proxy, test one. So I'm taking the request path parameters, right? So here the path parameters has a proxy here, right? So this is a hard-coded JSON, guys. And I'm giving a path parameter called zip code. And then I'll pass 1, 2, 3, 4, 5, some junk. It doesn't matter. It just gets passed to my method, to my function as is. Click on test. And it's making a DB call now, right? Oops, it's making a DB call. Hey, incorrect result set size, expected 1, actual 0. Because let's take a look at the logs here. CloudWatch, because I passed CloudWatch, go to log groups and weather Java. Okay. See the zip code from path param is 1, 2, 3, 4, 5. You don't have 1, 2, 3, 4, 5 zip code here. That is why it's throwing an error. Okay. So I'll change this to 5, 5, 9, 1, 2, 3, 4. I'll change it to something that exists here, 9, 1, 2, 3, 4. So my unit test failed. Configure test event, 9, 1, 2, 3, 4, I believe. Okay, save it, test it. There you go, status code 200. You have 112 degrees here. It made a database call, my unit test. Well, we got the function ready. Now let's go to API Gateway. Let's create a new API. REST API. REST API. I'll call this weather as a weather API itself. I'll call it weather, and it's a regional. REST API, new API, weather, sure. And within weather, let's say somebody can call it. Now I'll create a resource called, I can do a couple of ways here. So do you want somebody to call this slash itself? Slash is a resource, and then you can add path parameter, or you can, within this, you can create a weather. So it's a slash weather slash zip code. That's what I'm doing here. Slash weather is a resource here. Okay. Slash weather is a resource, and within that, I'm going to create one more resource. What's that? Zip code. And here I'm passing as a path parameter, guys. Here you have to use these curly braces. So you have to use these curly braces. Then it thinks that, okay, slash weather slash 1, 2, 3, 4. Now 1, 2, 3, 4 will be used as your path parameter, and it will be passed as a path parameter to my Lambda. Does it make sense? Create a resource, and I have a slash weather slash zip code as a path parameter. Now I'll make a method HTTP get on this guy. So if somebody makes a slash weather slash 1, 2, 3, 4, 5 HTTP get, then I want this to be a proxy integration. Yours is to my Lambda function. What's my Lambda function name is weather-java, and save it. You're about to give permission, sure. That's it, guys. So click on test, and it's asking for the path variable. Okay, give the path variable, let's say 87654. 87654 is one of the zip codes. The last guy here, 12 degrees F. Let's see, and let's test it. 12 degrees F. Okay, let me pass 12356. 12356. The second one from the top. What's the weather? 18 degrees C. 18C. 18C. It's how about 48375? 48375. I'm unit testing. I did not deploy this guy yet. 48375 is 57 degrees. Beautiful. Now I'm pretty happy with the results. Let's go ahead and deploy this API, and I can do QA for this particular new API. This is the API, right? So this is the endpoint URL, and then what is my path here? /weather, and then you have a /zip code, whatever the zip code is, and then let's say 91234, 91234. Zip code equal 91234, 112 degrees. This is the guy. And 80013, 51 degrees. Yeah. I'm passing this to you guys. Go ahead and test it with all the test data. I'll keep my this guy open so you can test your API. You can test our API with any of the zip codes. And of course, you can test with something that doesn't exist, and we can see what happens too. Internal server error, you get 500 because your Lambda failed. And that's not the best user experience. Ideally, you want to handle that gracefully, both at the Lambda level and also at the API gateway level. But that's fair. So that's it, guys. Any questions? This is exactly the state that I wanted to be. And this is your URL. And now what you can do is you can play with your Route 53. And number two, you now go to your S3 static website hosting, create a simple HTML and put this link there. Ask them to, or put a simple text box and submit button there. Ask them to enter the zip code and then call this API. And whatever the response you got it in the JSON, you parse it and show it in the browser in a fancy way. That's your website. Yeah, it's your serverless website. Now what we have seen is a serverless API, and with a bunch of serverless APIs, you can build a serverless website, and you can build a serverless mobile app. You can build a serverless anything. We talked about various examples yesterday, Kinesis Stream and all.
Venkat, quick question here.
Absolutely.
Maybe I missed it. So why do we have that /QA in the URL?
Okay. This one, right?
Yeah.
So this is something called, they call it stage. Okay. It's a stage variable. So it's an environment. So are you calling this URL, /dev/QA/prod/ you have various environments, right? Your sandbox, dev, QA, stage, prod, prod v1, prod v2. So by maintaining different stage variables, you'll be able to deploy it, and the same results and your sub results and your HTTP method, everything you'll be able to deploy your APIs to multiple stages. Same API, you are deploying it in multiple environments. You want to first, put it in your sandbox environment, have your developers test it. Put it in QA environment, have your QA people test it. Put it in your staging environment and have your business users test it. And then if everybody gives a sign off, then put it into prod. Make sense?
Sure. Yeah. Where did we configure that? Like.
Oh, okay. Where did we configure it? See here in the stages. So
Okay.
what we will do is when it is time to deploy it, after you create an API, when it is ready to do the deploy, so click on weather again. So currently this guy is tested, is in QA, right? So what you can do is go to resources, click on deploy this API. Do you want to deploy
Okay.
to QA, or you can deploy a new stage here and let's say prod. I'm putting in a prod v1 or, okay. This is in prod v1 state now. And this is my URL. You see that?
Sure.
So it's a different environments, and you absolutely want to have that. It's a good idea. It's a very good idea. Irrespective of whether you are using Amazon API Gateway or not, but you know, even with AppG or any other API gateways. So there's a concept of environment, and these guys call it stage. Like how you code, how your code goes, you know, from local to production, right? It's a different environments. And the beauty, I'm glad you asked. The beauty here is that you can maintain different versions of it. So now your prod v1 is pointing to one microservice, and you can go with the prod v2. You can have your prod v2 point to a different microservice, meaning different Lambda in this case. Does it make sense? As your backend changes, so you can give v1 to certain clients and v2 to certain people. Let's say you have 1,000 clients, okay, and you wanted to test your v2 functionality because you don't want to, you know, go disrupt everybody, right? That's exactly how Facebook does it, Amazon does it, Google does it. They call it canary deployments. So they'll just test that new piece of code on a small set of people, okay? Or Facebook, like people, they randomly select it. So out of, let's say, 1 billion Facebook users, when they want to test some new functionality, they just test it on 100,000 people, randomly selected 100,000 people. Only those people will get that new code, okay? And then they'll get the metrics. Based on that, they'll slowly roll out to the rest of the people. So this is how you can maintain your versioning here. They call it stages. Yeah?
Yeah, that makes sense.
Wonderful. So let's, Vamsi will join in 5 minutes. So let me stop recording here.